Hello everyone. Today we'll be looking through Archimedes Principle, very important principle in hydrostatics. Let's start. So Archimedes Principle, put simply, is a law that states that when a body is partially or completely submerged in a fluid, there is a force that acts upon the body called upthrust, which acts opposite to the force of gravity. Now, the magnitude of this upthrust is equal to the weight of the fluid displaced. So we can write the equation form. We can say that U is equal to W subscript F, where F means fluid and W means the weight. Now, this right here is where we get the principle of density. Now, if you don't know, density, that's represented by rho, is equal to mass divided by volume, and whether or not an object will sink or float is determined by its density. So if we put on, let's say for example that this ball is denser than water. When you put the ball in the water, it's gonna sink, and the reason for that is because it has more mass per unit volume, it will be displacing a certain amount of water whose mass cannot match up to that of the ball, and therefore the upthrust acting on the ball will be less than the force of gravity acting downwards, which is why dense objects sink or float. So whether or not an object sinks or float is not about how heavy it is, but rather how dense it is. Now, from there we can move on to another very important part of Archimedes' principle, and that's the pressure. Now, in physics, pressure is described as the force acting on an object per unit area, and so we can write that as P is equal to force over area. Now, this formula here isn't very useful when dealing with hydrostatics. This formula is more for dealing with solids. So what we have to do is we're going to have to derive a formula that can be applied to hydrostatics. So we'll go ahead and do that. So we'll rewrite our formula. P equals F over A, and then we will start changing the formula so as to apply to hydrostatics. Now, the first thing we want to do is we want to look at force. Remember that weight itself is a force. Therefore, we can rewrite this as P equal weight over area. And then we can go ahead and we can remember that the weight of an object is equal to the object's mass times small g, which is the gravitational field strength. Therefore, we can rewrite this as P is equivalent to mg all over A. Now, right here we have area. What we can do now is we can rewrite area in terms of volume and height. And now we're working better with hydrostatics, because if we look up here, we can see that there's a certain amount of volume in this, and it has different heights at different parts. So height and volume seem like they'd be good to have in the equation. So we can rewrite this as pressure is equivalent to mgh all over v, and this is because area is equal to volume over height. This is for a prism, by the way. We are working with a prism, for example a cylinder, and the area would equal to the volume divided by the height, and so if we swap area volume divided by height, we end up with this right here. Now, as we said before, density is equal to mass over volume. Therefore, mass is equal to density times volume. So we can rewrite this as pressure is equal to density times volume times G times H all over V, and we can cancel V and end up with pressure equals density times G times H. And this formula here is very important. You need to understand the formula as well as the derivation that we just did. Both are very important for KXE. So now looking at this formula, we have pressure is equal to rho GH, or density times G times H. And so basically what we're saying is that the pressure, the water pressure acting in this container would depend on the height at which the water is. So for example, if you were to burst a hole here, water would come out with more force than if you were to burst a hole here. And we can reason this because the water at this part would be experiencing more pressure due to the fact that it has to carry the weight of all this water above it. And if we're dealing with weight, then gravitational field strength would come into act as well as density. So simply put, that is Archimedes principle and how we relate it in terms of the pressure and the object floating or sinking. That's all for this video.
Tell me pretty lies, look me in the face, tell me that you love me.